so we're going to do this problem here in Haskell and also Python, so we can get a feel for how they're the same and different. So our task is to make two functions, max and min, or maximum and minimum, depending on the language. They receive a list of integers as input and return the largest and lowest number in that list, respectively. So we got a few examples. We're given a list, then we have to return the max. 566, negative 134. That's easy to see. The tough part is going to be how do we implement this in each of these languages. So we can do Python first, and then we'll translate our approach to Haskell. Yeah, I think that's the plan. Okay, so we have to fill out these two function definitions. So I already have something going for us. So basically what's we need to make here is a function where if we give it this simple list, 1, 2, 3, it should return 3 for maximum and 1 for minimum. So let's think about this. So I'm going to do a recursive function because that's how most functions are done in Haskell. And I want to match that in Python. So we need to think of our base cases. So our function takes in one input, a list. What happens if that list has length 0? What should we do? This is debatable, but for now we're just going to return 0. Next question, what if our list has a length 1? Then we just want to return that single element. And then what about if it has length 2? In that case, we want to pick the minimum of the two elements. So how do we do that? We'll say L0 if L0 is less than L1. These are the two indexes for a length 2 list in Python. Otherwise, return L1. So if you had, 1, 2, then we're going to return 1 if 1 is less than 2. Otherwise, return 2. So we'll return 1. Okay, so now the fun part comes. If we get a list of size 3 or more, what do we do in this case? So let's walk through an example just to get a better sense of what's going on. So we'll use this. This is a note for later. So what are we going to do here if we got a list of size 3? So let's see. So I and j. We're going to look at the first two elements. And then just to show you that this is going to be for minimum, we're trying to define the minimum function here. So what are we going to do here? We get a list of size 3. We got 2 pointers on the first and the second element. We're going to compare these two. We're going to say our head, which is the beginning of our list, is going to be, this. We'll use this same function. Our head is, in this case, is 1 because 1 is less than 2. And we're going to append the rest onto head, or extend, head.extend rest. And that's going to be 1, 3. So we start with this list, we compare the first two elements and get 1. And then we're adding the rest of the list onto our head, and then we're gonna redo this function. We're gonna call minimum on 1, 3. And now we have a size 2 element. And so we're going to go into this one. So we'll say L0 if L0 is less than 1. In this case, 1 is less than 3, so we're going to return 1. So this function will return 1. So so what do we do here? We get a list, we compare the first and second element, and choose the smallest one. And then we add back the remainder of the list that we haven't looked at yet. So in this case, it was 3. And then we call the original function again with that new list. So how do we write this in Python? Let's say our head is, it's going to be a list, and we're just going to copy this. We're going to look at the first 2 elements. So our head is going to be the smaller of the first 2 elements. Battery's running out. All right. Our head is going to be the smaller of the first 2 elements, and then we're going to extend that list with the remainder. So how do we do that? Head.extend. And we've already looked at the first 2 elements, 0 and 1. So let's grab 2 all the way until the end. So we've extended our head, and now let's return minimum of our head. And the reason we have to do this is because of this right here. This extend function, it doesn't have a return type, so we can't, add this as the variable here. So we have to pull it out like this. So let's test our minimum function and make sure it's working correctly. Let's give this a pass. Let's comment this out. Then let's run this Python. Oh, right. We've got our notes up here. Comment those notes out. Let's try this again. We're hoping that we're going to get 1 back if we give it 1, 2, 3. Okay, cool. We're good. So we've written our minimum function using a recursive function. Let's take that same approach and write our maximum. And it's actually going to be, mostly the same, except we'll take the biggest number instead of the smallest in a couple of places. So here, we're going to flip that to greater. Same thing here, we'll flip that to greater. And we're going to return the maximum. So same thing as maximum, same thing as minimum. We're just returning the greater number when we're comparing 2. So when we call maximum on this list, hopefully we're getting back 1. When we call minimum, hopefully we're getting back, we want 3 for the max and 1 for the minimum. So let's check. All right, so there we have it. We've written our recursive function for minimum and maximum in Python. We can go ahead and test this by putting it in here. Cool, looks good. Next we can do this in Haskell. All right, so let's try it again. So now we're going to do Haskell. And we're going to try and use the same implementation, kind of do a recursive function, but we're going to see how this happens in Haskell. It's going to be a little bit different than Python. Okay, so let's open our Haskell file. So we got these 2 functions, and actually it's a little bit messed up. Like, this is a reserved name for a built-in function, so we have to name it something different. I just chose to put a 2 on the end to show that this is something different than whatever is built in. Okay, so all right, so how are we going to write a recursive function to give us the minimum of a list? So we can use pattern matching. It's actually a little bit, I can keep the, can keep this open for reference, the Python implementation, so we can see how they're the same or different. So we'll do the minimum first. We're going to use pattern matching. So we're going to say case L of, and now we're going to look at all the different cases. So we could have an empty list. In that case, we chose to return 0. We could have a list with one element. In that case, we chose to just return that element. We could have a list with 2 elements. And in that case, we're going to return the smaller. So how do we do this in Haskell? If else Haskell. Okay, got it. So if x is less than y, then x else y. I think that's what's going on here. Okay. So if we have 2 elements, we're going to compare them and return the smaller. If we have 3, x, y, rest. I guess we can call this tail. Let's call it rest. So the colon is a way to append an element onto a list. So like 1, well, let's see, 1, 2. Okay, so we can do the type of, so this is a function. It takes a element like a string or a number or something in a list, and it returns a list. So it appends this initial value onto the list. Okay, so if we have 3 or more, what are we going to do? We're going to return the minimum of rest. And then what's going to be the head element? We're just going to find the minimum of the first 2 values. And we already did that here, so we can just copy that. Okay, so what's happening here? First, we're going to compare the first and second element and return the smaller. We're going to append it to the remainder to create a list. And then we're going to call this function again with this updated list. We're going to do this continually until we get one of these terminal values, either empty list, list with 1 element, or 2 elements. So let's see if we can do that. Can we just load this? No, because this doesn't have anything. Oh, I'm in the wrong folder. J Haskell ls. Cool, there we go. JHCI. So let's load a.js. I think the issue is here. This is not defined yet, so we can just comment that out. Let's do that again. So now we can call minimum 2 on 1, 2, 3. It's going to return 1. Nice. So this is working as expected. So let's do maximum. So similar to how minimum and maximum are similar in the Python implementation, it should be similar in Haskell too. Except we're going to flip those comparisons. All right, so let's load that. Let's call it max of 1, 2, 3. Uh-oh, that is incorrect. Well, All right, so now we're gonna debug. This should be 3, but we got 2 for some reason. So how did that happen? Oh, wait, let's see. What's the maximum of 2 elements? That seems right. That seems right. Oh, because I'm calling minimum. Max. There we go. Let's try it again. There we go. All right, so this is how we do it in Haskell. Uh-oh. Oh. All right, you guys, there we go. So that's how we do some pattern matching on lists in Haskell. Thanks for watching.